back to Spring Into Math 8. I'm Mr. Burns and I'm your teacher for today. Today's great topic is scientific notation and measurement. So just a little quick fact. Did you guys know that the sun is 92 million miles away? Do you think you could write 92 million miles away in scientific notation? I bet you can. Alright, scientific notation is frequently used in mathematics and science. It's a way of representing very large and very small numbers and without having to write all those zeros on the end of that number. Okay? So basically it takes big and small numbers and makes it easy to understand in a small and compact way. When a number is written in scientific notation, it is written as a product of a number that is at least 1 but less than 10, and a power of 10. The large numbers greater than 1 are positive powers of 10. The small numbers that fall between 0 and 1, or your decimals, are written as negative powers of 10. Great piece of information you're going to be using. Okay, here's a few examples. I have 595 million, which has been shrunk down in a compact form of scientific notation to 5.95. That 5.95 falls between 1 and 10, and then you're multiplying that by 10 raised to the 8th power, because that's how many spaces I move my decimal over to make it fall between 5.95. Now, the next number we have here is a really, really tiny number. This is something you would need to use a microscope to see, in fact, okay? So we have 1.7 times 10 to the negative 11th power. That means I move my decimal places 11 spots, okay? So notice the first number is very large and it has a positive power of 10, and then the next number we have is very small and has a negative power of 10. So let's actually take a moment and break down the steps of actually how we use scientific notation. Okay, so my example here, I have step number 1. Move the decimal point so that to the right and the first non-zero digit of the number. The result should be a number that is at least 1 but less than 10. So down here at the bottom of the screen we have 490,000. Now that decimal is currently sitting, although you can't see it, at the very end at the last 0. And we need to move that decimal place over to the left as many times as we need to make a number that falls between 1 and 10. So I moved it over and I came up with 4.9. That number falls between 1 and 10. So step 2. Count how many spaces you needed to move the decimal point in step 1. The number of spaces will be the power of 10 you're using, or your exponent. If you move the decimal to the left, it will be a positive exponent, and if you move it to the right, it will be a negative exponent. So let's take a look at what we previously just did. We had 490,000. I had moved my decimal point over enough times to make 4.9, which falls between 1 and 10, which we have to do. And I counted it, and I actually moved the decimal point 5 spaces. So let's hold on to all that bit of information and write out a final example answer. So we're going to take what we learned and what we solved in step 1 and in step 2 and combine them. Okay, so we got that 4.9, which is the first part, and we times it by 10. We're always using 10 as that base, and we move the decimal point 5 spaces. Okay, so that means that we have now an exponent of 5. So now I can say with confidence that 490,000, which is a big number, can be shrunk down in an easy, compact way to understand. And we got 4.9 times 10 to the 5th power. That's it for today, guys. I hope you learned a lot about scientific notation and the steps that go along with it. Catch you next time.